Lesson 1.3, 1.4, we're going to be analyzing functions and talking about functions in domain and range. So when we're looking at functions, there's 4 ways to represent them: verbally, numerically, graphically, and algebraically. Now, to test for functions, you want to make sure that each input matches with exactly one output. So if you have an input value that happens twice, like let's say you have an input value of 2, you shouldn't have 2 equals 5 and 2 also equals -7. You could have 2 equals 5 and 2 equals 5 again, but you shouldn't have 2 different outputs for the same input. So let's look at example 1. We're determining whether the relation is a function. So A, the input value x is the number of representatives from a state, and the output value y is the number of senators. This is a function because no matter what the value is for x, the number of representatives, you're always going to have an output of 2 senators. Each state has 2 senators. So each x is going to have exactly 2 as the output. It's not going to have different outputs because there's only 2 senators for each state. So A is a function. Okay, B. Let's see. 2 goes to 11. So we have 2 twice. So 2 goes to 11 and 2 goes to 10. 3 goes to 8. 4 goes to 5. 5 goes to 1. So since 2 as an input gives you 2 different outputs of 10 and 11, then it's not a function. Because remember, it has exactly one output. Graph. I don't have one here, but some examples of graphs. So let's look at that, and let's look at that. And let's look at absolute value. Okay, so looking at a graph, each input has exactly one output on this. You also can think of this as if you draw a vertical line, it only crosses once. That's called the vertical line test. So this graph is a function. Here, there's a graph where I could draw a vertical line and it crosses twice. That means 2 outputs for 1 input. So this one is not a function. Here I can draw a vertical line and it only crosses once. No matter where I draw it, it'll only cross once, so that is a function. For part D, you'll want to solve for each variable. So if you solve for, let's solve for y, because that's easiest. You would subtract x squared to the other side. And so y is going to have one answer, which means there's only one output for each input, so that is a function. Then for part E, I spaced that weird, sorry. Let's solve for y. So I'm going to add x to the other side. I then need to take the square root. And whenever you take a square root, you get plus or minus. And here we see that we get 2 different y values. We get a positive y value and a negative y value. So if I plug in a number for x, I'll get 2 different answers. So this is not a function because I'm getting 2 outputs. All right, example 2. So that was talking about functions. Now we're going to talk about function notation. When you see the notation like that, that is telling you to plug in 2 for x. So we're going to do that. -2 squared plus 4 times 2 plus 1. You're going to square your 2 and you get 4. 4 times 2 is 8. Add those all together and you get 5. So that is g of 2. g of 2 equals 5. All right, g of 2t, they want you to plug in 2t for x. So that would be negative 2t squared plus 4 times 2t plus 1. If you square 2t, you're going to get, there's a negative out front, but on the inside, you're going to get 4t squared. You multiply these, you get 8t plus 1. And there's no other simplifying you can do. So g of 2t is negative 4t squared plus 8t plus 1. X plus 2, they want you to plug in x plus 2 for x. So it'll be negative x plus 2 squared plus 4 times x plus 2 plus 1. From there, you're going to simplify it. So you're going to have to FOIL this. X plus 2 squared, you're going to multiply it together. So that's going to give me negative x squared, 2x, 2x, and 4. Okay. From there, let's distribute the negative and distribute the 4. So I just distributed the negative. Now I'm going to distribute the 4. And you have plus 1. And then collect like terms. So I'm getting negative x squared. If I put these x's together, they actually cancel. If I put the numbers together, I get 5. So g of x plus 2 is negative x squared plus 5. All right, moving on to example 3, we're going to look at evaluating piecewise functions and graphing them. So if I plug in negative 4 into the function, you always start by looking at the number and determining whether it which piece it fits into. Negative 4 is less than 3. So that means it goes, that's where. So first you locate which piece. We know it's the first piece. Now that I know it's the first piece, you plug it in for the x value. So it'll be negative 4 squared, which is 16. So negative 4 is 16. Let's plug in 7. So 7 is greater than 3. 7 is greater than 3. So that means the answer, since there's no x to plug in, the answer is just 13. Because there's no x there in that piece. 0 is less than 3. So that is back to the top piece. So you're going to have 0 squared, which is 0. 3 is the middle piece. 3 is equal to 3, so you're going to plug it in for that x in the middle. So you're going to get 5 minus 3, which is 2. And then 2 is less than 3. 2 is less than 3, so we're back to that top piece. And you're going to have 2 squared, which is 4. So that's how you will evaluate a piecewise function. And now to graph a piecewise function, you can make a table of values like we did here, or you can, that's probably the best way to do it. Let's just do it that way. So let's plot these points that we've got. Negative 4 is at 16. Okay, 7 is at 13. Zero's at 0. 3 is at 2. 2 is at 4. Okay, so we can plug in a bunch of points, and I can plug in all the in-between points as well to see what happens. So you could make a table, which we talked about in the first lesson, or you can graph these into different sections. So what I would start with is look at these numbers over here, and you're going to draw boundary lines. So these pieces are cut into, there's 3 parts, and they're cut at the number 3, because that's the number you see right there. So I'm going to draw a dotted line at 3. This is where the graph cuts into pieces. Now, the left side, so when I say left, I mean less than 3. So left of the dotted line is x squared. And so that is a parabola. And if I plug in 0, I get 0, which is why I have a point there. If I plug in 1, I get 1, because 1 squared is 1. If I plug in 2, I get 4, which is why there's a point there at 2, 4. If you plug in negative 4, you get 16, which is why there's a point there. 1, 1, 2, 4, or negative 2, 4, and then negative 3 is at 9. And so you're seeing that it makes a parabola on the left side. Oops. 3 would be 9 if it was there. But you got to put an empty circle at 3 because it is not equal to 3. It's only less than 3. Then we have a filled in point at 3. That's the middle piece. That's the middle piece. At 3, we got 2. And so that's why there's a point at 2. And then you've got the right side, which is when x is greater than 3. That means to the right of the dotted line. And the answer is 13. So no matter what point you plug in, it's always 13. So we already have 4 is 13. So 3 is 13. 2 is 13. Or that's not 2, sorry. 7, 6, 5. 4 is at 13. And 3 would be at 13, so we're going to put an open circle there, but it's not equal to. So we actually have a constant horizontal line there. So this is a graph of the piecewise function. So you just graph the graph given to you, but you only graph it to the left of 3, at 3, and to the right of 3.